Good morning. Welcome everybody. It's my time now to start marveling, so talking, and people outside they will listen and will come. Yeah. Okay. Let's see. I hope you had a great night and you don't have any hard hangover. For those that haven't been in any of my session, my name is Nico. I'm a major from the Greek army, and I'm working in the center for the last 2 years in the technical branch. So our session is talking about Internet of Things. On the last day, always we are trying to pick something from the future. So we'll talk about the architecture, and we'll start from silicon to the platform. So we have 3 excellent gentlemen here, our panel. From left to right, we have Mr. Richard Cold. He's currently in Digital Shadows. He has experience in offensive and defensive security. He's certified SCADA security architect and holds a PhD in computer science. Welcome, Richard. We have Dr. Sahid Raza. He's a senior researcher in SIX, Swedish Information and Communication Technology. And recently he has a competitive research grant from the funding agency Vinnova, where he's also the project leader. And last but not least, we have Mr. Francisco Marotto. He's managing director and founder of OES Consulting, Internet of Things, and he has been in several companies: Microsoft, Oracle, Amdocs, SAP, HP, Vodafone, European Space Agency. Yeah. There's a lot of, yeah. Okay. So can we really secure devices that have constrained means like CPU, memory, battery? Is it possible? And what are the threats that are posing? So, Richard, the floor is yours.
Okay, thank you. Okay, is this working? Great. Let's get the clicker. All right, good morning, everybody. I appreciate this is the first session after the social event, which is possibly the worst session of the entire conference, so I apologize in advance. But, I'll try and keep things lively, try and hopefully entertain you and maybe even educate a little bit. So, when Nico asked about the Internet of Things, my first reaction was, well, it's more like the Internet of Threats, and that's what I'll try and convince you of during the course of this presentation. So let's start with a few definitions. What is the Internet of Things anyway? Well, back in the day when I started on this kind of work, we called them wireless sensor networks, and that's maybe a more descriptive term. Internet of Things, doesn't really tell you anything. So what are they? They are tiny computers which have the ability to sense the environment. So that can be something like sensing temperature, sensing light, sensing air pressure, maybe even chemical compositions. For like pollution, for example, is one of them. And also, this is also pretty interesting, to potentially influence the environment through actuation. So that could be like locks, valves, relays. So there's a lot that you can do. And then we're also going to talk about what the threat landscape is. And that's a phrase that we use quite a lot in security, but if you're not that familiar with it, it basically just means the different types of threats an organization, a system faces. That's pretty much it. So, IoT devices, what do they look like? Well, here are some examples. We've got a door lock there, which is operated through a wireless controller called Zigbee. Carbon dioxide monitor. Here in the middle at the bottom, this is for people who have diabetes, so measuring the insulin in the blood. And then on the bottom left corner, have a thermostat by Google Nest. Nest being a company that Google bought. And we'll come back to the Google Nest in a little bit. So this is the sort of things that we're talking about. You see the form factor, pretty small, pretty compact, typically wireless. So the vision of IoT is grand. It is, almost one could say utopian. So, if you look for images about IoT, this is the sort of thing that you find. An entire city instrumented with millions of sensors, connected, talking to each other, exchanging information, for everything. You've got water, you're talking about financial stuff, talking about electricity, power, environment, or transportation, everything. Now, for some people who are very optimistic, this looks like a pretty cool future and something that we really should be embracing. For a security person, you're starting to think about what the devices are, how they're connected, who owns what kind of control can you exert, and the IoT vision kind of quickly degrades into the reality. And I think this is the best definition of IoT. There is no IoT, it's just other people's computers in your house. And here we have Maria Moa, who is a Norwegian security researcher who unfortunately had a heart attack one day and had to be fitted with an emergency pacemaker. And turned out that this pacemaker had a wireless facility, so you can talk to it over a wireless network, and it has bugs in it, right? It's, pacemakers these days are software. Everything is software these days. Software is eating the world, and it had some bugs. And if it has bugs, it might have security bugs. So she started to think a lot about this. And the reality is, she's living now, she has a great talk called Go Ahead Hacker, Break My Heart. And it's about living with a vulnerable device implanted in you that you can't get rid of. In the middle there is the infamous Jeep hacking stunt from Black Hat last year. And we'll come on to that a little bit later. And on the far right there is disassembly of the code from Stuxnet. That's something that should need no introduction to an audience such as this. So these vulnerabilities in the IoT can come from very unexpected places. And in some sense, there's almost comedy associated with this. So Tavis Ormandy works for Google Project Zero. He breaks any software that comes close to him. So, as you see, it's like finding a security hole in a bathroom scale is, ridiculous, right? This is a joke, But as he says, if you're not familiar with the technical details, what that basically means in the bottom tweet there is that this is pretty much the worst kind of vulnerability you can find, right? This is really serious. So, you should take care of it. So if you imagine you had this Fitbit, which is the bathroom scale, in a network which was actually kind of important to you, maybe it contained some sensitive resources, maybe it was in an office building where interesting work was being done, then you could use this to get in, basically, to penetrate the border defenses of that network. And it might not be something you immediately think of, right? So people were thinking, well, I've got my firewalls, got my perimeter devices, my border routers, I've got my access control lists, I've got it locked down. But then some clown comes along and installs a bathroom scale, and somebody gets into your network. That is really not what you were expecting. So this is what I mean when I talk about the Internet of Threats. It can come from very, very unexpected places. So currently, it's estimated, from 2 years ago, 3 billion or so devices in the Internet. That's quite a lot. And this is, of course, the hype, right? This is worth keeping in mind. The hype is that it'll be over 6. And I appreciate that they put the 6.4 there to show how precise they are in these future predictions. But we can expect that there's going to be a lot of these things. And probably way more than sort of devices that we have now on the Internet. And the devices that we have now on the Internet are pretty powerful devices. You think about your laptop, think about your tablet, think about your smartphone. If you look at like the iPhone 6S or one of the Samsung Galaxy, the new ones, these are devices that've got a lot of power, a lot of CPU, a lot of memory. They've got a lot of storage. They can do a lot. The iPhone 6S has some really nice security features, right? So that they're really putting a lot of effort into it, and you can really see the results. But for these kind of tiny devices, where you really are struggling to get everything working there, to get everything to fit in there, then you may have some issues. So if we see that the attack surface is a function of the number of devices and the software that they're running, then sort of doubling, tripling, whatever the number of devices significantly alters the threat landscape. That is the type of threats that an organization or system can face. And the sort of significant changes that they introduce are things like what attackers can do and which attackers can do it. So in terms of the what, so there's, we've talked a lot about in CyCon about, cyber physical attacks or cyberkinetic attacks, or however we want to do it. And, things people are mentioning Stuxnet, against the uranium enrichment facility in Natanz, or they're talking about the attack on the Ukrainian power system last year. And, the fact that I can name these things shows you how unusual they are, right? They're rare, but they happen. And that's partly because the critical infrastructure, it's fairly specialized, it's fairly esoteric. You've got to kind of really know what you're doing. You can't just, it's not the same as like breaking into a Windows PC or something. But in the case where these sort of devices which have this kind of almost inherent vulnerability, when they are instrumenting our entire lives, from, when you get up in the morning, the climate control in your home, to the lighting, to the water, to the electricity, to the transportation system you take to the office, to your office, to the HVAC in the building, to everything, what you can do to a target changes. And it's interesting that that when the president of Estonia was talking, he was really, focusing on these integrity-based attacks. So if you think about CI&A, confidentiality, integrity, and availability, which is the sort of the CIA for security, not that CIA, another one, then integrity would also be pretty horrible if you could change what devices could see or feel about the world that they're existing in. So if you can tell it that it's cold when it's hot, and these kind of things, you can do a lot to influence the environment in a completely unexpected way. And, self-driving cars, that would be a pretty nice thing to take control of, right? If you were a malicious attacker, of course. Just make that clear. And also which attackers can have access also changes. So before we've talked about, these cyber-physical attacks, it's either a nation state or a suspected nation state support, it's that kind of a level. Again, we're talking about the more boutique threat actors, right? Because there's a lot of specialist knowledge, as I mentioned, that you need to have in order to pull these things off. But if these systems are really vulnerable, then the barrier to entry gets dramatically lowered. Right, so you're not just talking about the sort of the Stuxnets of this world, you're talking about the sort of complexity that a lot of cyber criminal groups, and I don't even mean like the Carbonac, high end, but the sort of the basic, not completely basic, but the sort of, let's say the mid-range. It's a good way of putting it. The mid-range. The Zeus, the Drydex, that kind of stuff. The mid-range cyber criminals. This puts them on the map for doing cyber physical attacks. Think about ransomware, where you get some malware on your PC, it encrypts your files, and you can only decrypt it if you pay some Bitcoin, you pay a ransom. Could you ransomware somebody's house? And one person has mentioned on more than one occasion that if you think about this smart home, which is instrumented with all of these IoT devices, then having your smart home hacked and being haunted are actually the same thing. And you would not be able to differentiate between these two phenomena. Interesting thought. Also hacktivists. So there's, the sort of the guys who are just hanging out on Twitter and, doing the odd DDoS attack. Yeah, okay, it's still probably out of their range. But if you think about somebody like Phineas Fisher, who broke into Hacking Team and Gamma Group, this guy had some pretty serious skills. So this sort of a person would absolutely be able to conduct a cyber-physical attack. So this to me, these two things together perform pretty significant change. So you may be asking, well, if this is also serious, surely people are taking care of this. Security, it's important. Every company that ever gets hacked, the first thing that they say is that we take security seriously. But I would say that there are two main themes which work against that narrative. The first one is that security is actually difficult. People who actually work on securing systems for real know that it's really, really difficult. When you're really into the weeds, to the details, to really secure a system, you'll know it's very, very, very difficult. Yeah, the tools that we have simply aren't that good. So if you think security is difficult when you have a network of machines which are very powerful, then you're going to find IoT much, much, much harder. Because these devices inherently, right? Inherently, because they're tiny, just physics, it's there whether you like it or not. They will have less resources in terms of processing power, memory, and storage. They will typically have unreliable power supplies. Either it's some kind of battery, maybe some kind of solar power. I mean, if you're lucky, it's wired into some kind of mains, but you can't rely on that. If you think of, for example, cars. We had a talk earlier on drones, on UAVs. And also, the network is not so reliable. And I mean, you all know how, Wi-Fi can be pretty flaky at times. There's a lot of people, you have problems with coverage, with dead spots. So you're not going to have the luxury of an Ethernet cable plugged in. So you're going to have issues with networking. But often the IoT devices will have their own kind of networking protocol. So not like Wi-Fi that you use, here with the CyCon wireless. It would be something specific for IoT devices. That could be something like Zigbee. That could be something like Z-Wave. That could be wireless HART. I mean, there's plenty of standards out there that people use. And just as an aside, I've done some work on Zigbee security, and it's really not that great. So it's not exactly inspiring. Which leads me to the second point, which is that the Internet of Things manufacturers have been really pushed, let's say, to get stuff out, to get products to market, to sell things. And of course, when you're in a rush, if anyone's ever seen, either been part of or overseen a software project, you know that security is one of the things that usually gets pushed out when you're on a really tight schedule, because it's not a core feature. So if you're selling a lock, a wireless-enabled IoT lock, if it locks and unlocks, your product does what it's supposed to do, and you can sell it, and everybody's happy. So the sort of level of security systems that you may have, the defense-in-depth security model applied to your wireless door lock, you don't think people are really going to care so much. And IoT security now is pretty much how IT security was back in the 1990s. So it's all the tricks that worked 20 years ago are making a comeback. And we'll have a look at a couple of examples because it's quite fun. So my assertion is that the Internet of Things is inherently more vulnerable than the internet that we have now. And, as it has probably not escaped your attention, the internet that we have now is not the most secure thing in the entire world. And, there have been cases of people being broken into. So let's see how it works out. So just a sort of very brief overview of what an IoT deployment is. I'm not going to go into the detail here, but what I want you to see from this slide is that there's a lot of stuff that's there, right? There's a lot of boxes, there's a lot of arrows. And you can think in terms of an attack surface that you've got, well, the sensors and actuators which are interacting with the environment. You've got the devices themselves which have various software components, operating inside of them. The devices are talking to a gateway. That could be something, like your home router, your set-top box or something like that you might have at home. So you might have to have another one of these just for talking to IoT. There might be convergence one day, but at the moment you probably have to have a separate box. And then your IoT gateway is talking over the internet to some IoT backend, which is where all the data is collected and everything is analyzed and crunched and looked at. And that's you've got a lot of points there where bad things can happen, where things can be intercepted, where things can be compromised, where integrity can be violated. Or any of the CI and A are an issue, right? If your smart home if you can't access your smart home and you're inside of it, that's kind of, that's bad. And that happens actually surprisingly often. There's a very, very funny Twitter feed where they collect sort of horror stories that people have had from their IoT deployments. And the guy, they wake up in the morning and they just can't access the wireless network, so they can't, control their home. They can't use the thermostats. It's winter, so what do? Oh, you wait for a patch. Really? Okay. And then and in some cases you might even have the IoT devices talking over the internet directly to some kind of backend. And the focus of this talk is more on the devices, but just think for a moment about the data that's collected. If you want to profile somebody, or profile a group of people, or profile an organization, and you have access to all the information about what they do on a daily basis, this is really going to help. This is really going to help your efforts. And this information could be extremely sensitive depending on where these sensors are, what kind of data is being collected. And this may all be happening without you being really aware that it's going on. Because you'd have to look, if you were looking at a place like this, you've got all the lighting, you've got the AV equipment, you've got the HVAC, so for climate control, maybe locks, there's so much information. It's such an information-rich environment to play around with. So, yeah, so this is pretty much what I was saying. Not only the devices, not only the things, but also how they talk. And David Petraeus, who some of you probably have heard of, has got a pretty interesting point there. All connected to next-generation internet using abundant, low-cost, and high-power computing. So this will, clearly the intelligence value of this is already being seen. So I'm just going to round off with a couple of examples because they're pretty interesting. So GCHQ, Signals Intelligence Agency of the UK, forced to intervene to prevent a catastrophically insecure smart metering plan. So the smart meter, being in your home, monitor your electricity. So they said, right, it's got to be secure, so we'll encrypt the data. Great. However, they used the same encryption key for every single smart meter that was going to be deployed in the United Kingdom. So if you break into one, you have access to the data of any of them, because you can use the same key to decrypt any communication from any smart meter in any home, or I guess also a commercial facility in the UK. So that was bad. Google Nest, as we mentioned earlier, this one was pretty interesting. So in all fairness to Nest, they didn't do a bad job, but they just didn't consider every single possible angle, which is understandable. But in this case, they were able to, the attackers were basically, they needed physical access. Okay, so that already kind of raises the bar. But the Nest did not did not authenticate the updates that were pushed to it. So you could basically push your own updates to it. You could connect locally, push your own updates to it, take control of the device, use it as a pivot into the internal network. So that was pretty interesting. And then, as I mentioned, the Jeep hacking one, it's quite a nice little picture there. So this I really like this. So just in the last minute, just to go through a little bit on this one, because it illustrates a very important point, that modern attacks, happen in stages. It's rare these days that you'll just find something on the internet, exploit it directly, and you're in, and you're at your destination, and that's that. So if you look at the stages here, it's pretty interesting. So they figured out that all these Jeeps were connected to the Sprint cellular network, LTE, 3G, whatever, for multimedia services. They were then able to also use the GPS, to access the GPS through this multimedia cellular surface and figure out where the Jeeps were so they could choose their target. In this case, they actually did this live to a reporter from Wired, scared him to death, basically. So the manufacturers said, well, yes, we have a multimedia cellular network, and we have a controller area network, which is where all the engine management systems and the brakes and everything else hang off of, but they are separated. And they were separated. They were separated by a device which, like the Google Nest, did not authenticate updates. So once they're on the multimedia cellular network, they got onto the Jeep, they could find where this device was that bridged the two networks together, installed their own software on it, and then had full access to the CAN bus and could take control of the steering wheel, the engine, the brakes, everything, door locks. They put the brakes on while the reporter was on the motorway and got him to, crash into the side of the road, which is the picture you saw earlier. I'm not sure exactly how safe this demonstration was or how much they sensationalized it for the media, but the technical part is absolutely true. So in conclusion, the IoT is a vision of great promise. As I said, almost utopian in its vision. But from a security perspective, the reality is quite different. It's a very, very challenging area to do security at the best of times, and IoT makes that a lot harder. In terms of its effect on the threat landscape, it influences significantly what the attackers can do and which attackers are capable of doing it. And the security, in terms of the standards or the proposals for IoT, is usually pretty lacking. That even Zigbee high security is not that great. But by far the biggest issue is the implementation of these standards. They make very, very simple, basic security mistakes that 20 years ago would have been a problem, and they're still making them now. And that these systems do, and may continue to in the future, influence the most sensitive areas of our lives. Thank you very much.
Thank you, Richard. We have time for some questions, if you're interested. Yes, please. He's behind you, just behind you.
Hello, Lauri Korsberg from Cyber Defense Institute. I am thinking about that you're saying that all the devices are basically too weak to be able to implement any kind of decent security mechanisms like we are using on the workstations nowadays. But at the same time, having the big backend, do you think it's feasible to actually implement more kind of like sensor type security solutions? Because it seems to be that the general trend is actually now to do it also with the workstations, as they are already considered inherently vulnerable. Do you think that might be a solution?
It's certainly part of it, right? So moving as much as you possibly can to a defensible environment is clearly a good idea. And to also balance what I was saying, the devices, even if you think about that form factor, what you can do in this form factor changes dramatically. And I have a Raspberry Pi on my desk at work that's starting to be like a little bit like this, quad core, gig RAM. It's already quite a powerful device. But at the same time, there's also pressure to make these IoT devices even smaller, to make them less obtrusive. So I think there's always going to be this kind of struggle between trying to give them enough power to be able to implement. I mean, it's not just the cryptographic protocols. It's not just having TLS or having parsing an X509 certificate. It's also about storing information. So, for example, if you want to revoke a certificate, to say somebody, a website's been hacked, you will say, well, that certificate is no longer valid. I want it revoked. You have to have access to the internet to check whether it's a CRL or OCSP, but you have to have some connectivity to get that information. You have to store that information. So your requirements, just to be able to do one of the most basic operations, already puts quite a lot of burden on these devices.
Yes, please.
Karo Opio, NCSC Finland. Have you seen any attempts of actually standardizing the basic applicable good security posture for an IoT device, so that I would say the manufacturer community could actually agree that okay, these basic security measures should be implemented on all directly network-facing IoT devices or something like that? Has there been any attempts on that?
Thank you for your question. Actually, the purpose of Richard here is to frighten you, all of you. Yeah, we have also some countermeasures and what is going on security, but you can answer to that if you want.
Yeah, so I would say that so from what I've seen is that even when you have like a reasonable standard, the problem is getting that standard implemented. so that the actual devices implement what the standard says. Already this is very rare. And then the other thing is deployment. The devil is in the details. You can have a potentially secure system, but if it's poorly managed, you're going to have issues. And I think there's a lack of awareness of what the implications of the security issues are of these systems. And so when it comes to deployments, people go, well, it kind of works. You know, maybe they do a very, very basic check. But if you think about how closely we monitor our sensitive IT infrastructure, if you think about how the IoT stuff is monitored or not monitored, very, very different.
Okay, I don't think we have more time, but we have time for applause. Yeah, thank you,
very
Richard, for being here.
Thank you.
Click and grow, as always. So, Francisco, the floor is yours. Application level.
Yeah,
Okay.
thank you very much. It's a pleasure to be here today. I try to go as fast as I can. I speak very faster, more in Spanish, but also in English. So thank you very much, everybody, to be here today. It's my pleasure. It's a pleasure to be here in Tallinn for the first time, and it's a pleasure to talk about Internet of Things and in security. Because for the last 3 years, I've been talking and attending many events, and probably the only question that is repeated in every event is what about the security? So every people is interested about security, and at the end of the day, what happened is that not all the companies or not all the projects include the security. But security is a big concern for everybody. And I think that to realize the promise of the IoT, we need to make sure that we are able to convince the customer and to convince the companies and the government about the security. So let me start with this. And when I was preparing this presentation, I was thinking in how many breaches in the last 5 years, 10 years, and I found some reports that there's a company that is presenting every year a report starting in 2010. And when they started the report, they identified around 40 incidents. Last year, they identified around 300 incidents. When I said incidents, there are big incidents. The problem with the security is that it's not only in the Internet of Things, it's basically in everything. The companies, the governments, the customer don't want to relate that they have been attacked. It's something that all the community say that is good to know because we can prevent, we can implement more countermeasures, etc. But the reality is that we don't want to, unless some people discover that we have been attacked, we don't want to discover the attack. Because in terms of the brand reputation, in terms of the security of the employees, etc. So everything is very concerned about the security. And when I have this, and of course I have the standness, I have the hierarchy, but because I am the last one, I think, okay, maybe all the people has heard about all these kind of threats. And I was thinking in one TV show that maybe some of you have seen in the last 4 years, is the Americans. I don't know if you know or you are aware about the Americans. It's an American TV show, and there are some Russian spies working in the American. And I was, following the show, and in the last season, I see some examples about an attack from a spy. And in the last episode, I see, well, first thing is the preparation. So they take a lot of time to prepare an attack. The preparation was, okay, the same thing, nuclear, biological, etc. So they take for the governments a risk that the other government have something in advance or that can threat the other government. And these spies in the US, they are like an actor. They are very, very good actors. They can, make some camouflage. They can invent stories. But of course, they need to get the password. They need to also convince some people, internal employee. And I was thinking in this example yesterday, just not to talk about the StarNet, I say, we are in the same situation. If in the StarNet, if you see the StarNet in Ukraine, we have the same kind of behavior. We need to find some people internally that are able to open a file that can be include a virus, and we need to convince this guy to connect to the internet, and then we need to find the people who has access to the IT environment and the OT environment, and with this, we can be able to put a malware, etc., etc. So the situation is not different 40 years ago than the situation that we have now. There are the same risks, there are the same mechanisms to attack any kind of industrial or environment situation. Now, the difference is when I was thinking, okay, but these guys in the embassy or in the biological, they don't have the same thing or the same problem that we will have, not now, maybe in 10 years. Because you can imagine an office with smart printer, smart lighting, smart floor, everything will be smart, and everything will be connected. So it will be, and also the people who are working, probably they have some wearables. So there are many, many things that can allow in maybe 5, 10 years to think about different kind of attack vectors that right now we are not considering. Why? Because the Internet of Things, in spite, there are more than 20 years or more than 30 years that is present in our lives. Right now is with this growth of the number of devices, the different kind of devices, the different kind of networks, etc., is when we really are thinking about the threats. So it's not because we have many, many incidents in the last year. It's because we need to be prepared for the biggest target. And again, some of my colleagues talk, I think it was you, about the Google Nest. So Google was very happy last year, a couple of years ago, when they buy Nest. They pay a lot of, $2 billion? I don't know. They pay a lot of money because right now the Internet of Things is a big, big business for the investor and for the big companies. Everybody wants to be in the Internet of Things, and they pay. I don't know why they pay so much, because at the end, it was just only a small thermostat connected to the Internet. And I was talking with you this morning. I was working in the domotic smart home for more than 10 years, and there was on a smart thermostat, and why a company like Google will pay so much money for this kind of company? And then they buy another company, Revolve. And they close Revolve, and probably they will close Nest, because this is not the business, because when they have a problem, when they have an incident, the brand reputation of Google that never fails, that they make money, and with this company is losing money, and they have some threats that cannot compete, and the customer are unhappy, that can be a big risk for the company. So, and the other thing is, okay, if Google is present, there are many hackers that want to demonstrate that we can attack Google, we can attack the Nest. So, as much as the companies like Google, SAP, Microsoft, General Electric, Cisco, all these kind of companies, or the big companies like Siemens, etc., as much as they enter into the IoT, there will be more people that will want to attack, because this is very, very important for them to be reputed hacker, or also to discover some kind of, commercial or political information. So, again, what is the Internet of Things? The first thing I want to tell you, that I don't want to, again, repeat what is the Internet of Things, but that's only for your information. Right now, in this market, there are like two big names. The Internet of Things, in which every people talk about the smart home, we talk about the wearables, everything that is with the consumer, and the other word that we use is the industrial Internet of Things. So today I will talk a little more about the industrial Internet of Things, because I think that most of my colleagues have been talking about the consumer. And in the industrial Internet of Things, we will find that probably the opportunities are bigger than in the consumer, but also the risks and the threats are also bigger. I was just reading many, many reports from different kind of companies. And like I said at the beginning, there are many, many people asking for security, and many analysts asking and sending surveys to the companies in all the events and all the speakers. We said, is justified the alarm about security? And if you see, and that's the reason because I include here, if you see in this slide, if you ask to the people, then you find two different kind of answer. So, do you believe that the IoT device on this market are secure? And if you see the people, the enterprise, the executives, the business user, they said, yeah, almost yes. However, if you see the developers, and this is one of the most funny things, is that no. Why? Because they know that they are not implementing security. And I think that some of my colleagues also answered this morning about, are the manufacturing companies or are the people who are creating the devices included in security? The answer is almost no. So there are only a few companies who are implementing security, starting from the devices or from the chip. But right now, there are very, very few companies that can say, I have a secure 100% device or communication, etc. Why? Because Internet of Things is many things. Internet of Things, for instance, for companies like IBM, is the cognitive IoT, because they are more interested in the analytics part of the IoT. They are not interested in the sensing or in the protocol, in the communication. They are more interested in what can I do with this data? What is the value? Most of the companies think, or the value of the Internet of Things will be in the data. We are capturing millions and millions of new data, and well, if we know what we can do with this data, that will give us a big power. For other companies, maybe the telcos, important is more in the connectivity. Can we be a kind of a commodity? And we need to make sure that we can still make money with the connectivity, in spite of there are many kind of network. For the device vendor, the important is in the device. So there are many flavors of the Internet of Things. And this is another interesting interview, and probably the most relevant here is that this is made by AT&T last year, and the most important thing here is about the 10%. 10% of the organization, they said they are fully confident that the connected devices are secure. Only 10%. So it's a repetition that not all the companies now that the devices that are connected are secure. The other issue is, okay, if you are implementing or deploying insecure devices, why do you implement? And the other is, okay, this is now, it's right now, or the competitor can do it. It's an opportunity, it's a cost opportunity. So all the companies want to be the first. So the first smart refrigerator, the smart printer, every company who make a product, the first will be a winner in this market. The other thing that I want to tell you is that in the Internet of Things, there are many, many entrepreneurs. Because of this big opportunity, there are many entrepreneurs, there are many accelerator companies in every country, in all the universities, and many investors are just now putting the money to some people that are working in platform, devices, etc. And these people are small people, and they don't have the resources to make sure that they can implement a secure device or a secure protocol, a secure node or a secure application. And this is a very big risk, because the other thing that I am analyzing is, okay, once you have something in the field, and right now there are more than maybe 5 or 10 billion of devices in the field, end-to-end devices, because at the beginning we call end-to-end devices, it's very difficult for a company to replace and to substitute or to buy new devices. So what can we do with these devices? And because we don't have a standard, and we will talk later about the standard and the problem, etc., is with the next 2 or 3 years, because there are not a standard in spite of the what you said, etc. There is not a standard. Some companies are pushing for co-op, some companies are pushing for NQTP, for MQTP, and for many different kind of operating systems. Again, the companies like Microsoft, they will never accept to implement an open source. They want to implement the Windows 10 devices, and etc. etc. There is a big market here to make sure that we will have a standard in the short term. And if we don't have able to prevent right now what will happen with all the devices that will be, or not only the devices, the communication, the network, etc., that the companies are deploying, what we will have is in 10 years, it's a nightmare. Because once you have the network, one company, like for instance, the French company Sigfox or the new LoRa, etc., they implement this kind of networks over the world, and they have devices that cannot be completely secure, but they are working. So how can we make all the value of the Internet thing? How can this thing connect each to other? Or we can have island of devices, island of IoT or intranet of things. So this is a big risk that I think that we will cover. The other thing that I want to tell here is another 2 visions of the Internet of Things. There are the more business-oriented and there are the more academic-oriented. So if you see, for instance, in the academic-oriented, it's like, oh, the world is happy. The world is, we are very happy in this world, and we want to share all the data, and all the companies and all the people can use this open data, and then we can use it and live happy forever. However, there are the other part of this story. The other part of this story is the commercial, and we want to protect what we have. We invest too much in this, and we cannot share the data. Or if we share the data, we need to get some revenue about this. So when you hear about the new business model, like Uber, for instance, it's an IoT company. I was discussing with many people. Is Uber an IoT company? Is a car company? It's a revolutionary company, because there are, working in a new business model that is facilitated by some other for the Internet of Things. But they are not making too much money, at least at the beginning. But they expect to make a lot of money. So when you have companies in which the investor spend too much money to deploy a network, to create new devices, or to create a big environment in the cloud, etc., you have to expect that these companies want to make money. So there will be some kind of problem to open this data to other competitors, or to open this data to the normal public. So think about, there are two worlds right now: the academic world with open data, smart city, happy, and the business that is not so happy. And before I move from this slide, I'm working with this company that is Vision Research, and we create kind of a threat map for the Internet of Things. We evolved this from the machine to machine. So from the people who are now working in this industry for some years, you remember that 5 years ago, the world was machine to machine. In the Mobile World Congress, companies like Ericsson announced the 20 billion, 30 billion, they reduced, etc. I don't know that nobody now how many billion of devices will be connected in 2020 or 2025. But the reality is that the world is changing in the sense that with the machine to machine, what we have is just, let's say, vertical application for fleet management, for energy management. So there was like a vertical application, a vertical stack in which every company has his own solution. With the Internet of Things, and the power of the Internet of Things is when there are applications that you can build and they are not connected with any kind of silo. Then can be a kind of, in a way that you can publish something and some people can subscribe to this thing and use this thing to use it in his own processes. And with this company, we have been evaluating different kind of threats, etc. One of the most important things that we identify is there are many new interfaces, and there are many new threats that we can find. Moving up for this is a company or a project. This is an open web application security project, and it was very famous. They have a list of security for internet, and 2 years ago they launched a new report and a new information about the 10 IoT security vulnerabilities. When I was reading the information from these guys, and I see that, well, most of this information is relevant also for the internet. There are not too many new things, because there are not too many people who understand the Internet of Things. So what we have right now is there are companies who are, considering the cloud, the devices, etc., and working in, again, like in silos. So the people from the devices, the people from the cloud, the people from the connectivity, etc., etc. And there are only a few new, let's say, important things here that can, in my opinion, be relevant for the Internet of Things. And because I am now talking more about the application, for me, in terms, not the device or the communication, but in terms of the application, is who is building the application for the Internet of Things? So we have in the consumer, but let's forget for now because we are not working in the industrial Internet of Things. So who are building this kind of application? So there are engineering companies, there are the companies who are in the oil and gas, in the electricity, in the manufacturing, in the transportation, with maybe some system integrator or internal resources. And are these people prepared to write application and to develop application 100% secure for the Internet of Things? And the answer is not. Why? Because they don't have, again, they don't have standards. They don't have internally all the resources to develop the application, because security, well, in an IoT application, it's complicated. You have to cover the software that need to be running the device, the communication, the different kind of communication protocol, the interconnection between the IT world and the OT world. When I say that OT world is operational technology world, something like the SCADA, industrial control system, etc. So then you have to know more about the cloud, but there are not too many resources that know about the cloud. Then you know to know about machine learning. So there are so many things that is very complicated for a company to develop an application for the Internet of Things. Maybe in a vertical and for some specific problem or business need, it's easy. But if you think in the future IoT application, I don't think that there are too many people with the creativity and with the idea to create this kind of application. I think that we need to wait for at least 2 or 3 more years to find really IoT application. What we have now is, okay, we are working in the manufacturing. I know that, for instance, the company has been working, let's say, for instance, with Siemens or with Bosch or whatever. They have protocols that are proprietary protocols, etc. But maybe we can create a gateway and connect to the internet and hire some people to implement some kind of security, and then we are in the Internet of Things and we can present some white paper, etc. But the reality is that that's only, in my opinion, patched for what we will expect for the Internet of Things. Again, this is a presentation from a company that I am working now. This is Subes, and this is more related with the telecom sector. So the telecom sector, like the machine-to-machine companies like this company who has been working in the fraud management, the revenue assurance, they want to enter into the Internet of Things, and they create a platform to, in real time, because another big concept that we need to take into account is the real time. So in the industrial Internet of Things, real time, especially in security, will be very important. So if we have an attack, or if we can detect an attack, if we detect in real time, we can make some kind of action. We can control the threat. Otherwise, it will be too late. This is from my friends of Accenture, and I think also it's a little obsolete, because I include here because there are not many new reports or companies that really are updating the information about IoT. What they have is many information about machine-to-machine. They change the word end-to-end for IoT, and they present. But again here, then you will find like 3 big layers in the Internet of Things. You have the devices, you have the communication, and you have the application. And if you read, because I don't have too much time to go in this, if you read, it will be available, of course, no? Yeah, so if you read this, you will see that the attacks in the application are the same: the password, encryption, the authentication, identification, etc., etc. Not too big different from the other thing. I want to spend a little more time here. Who owns the problem? So we see that Internet of Things will make a big impact in our life, in our society, in our enterprise, probably in our employee. And because probably there are many people like me that think that in the future, the Internet of Things will destroy a lot of employees. So who owns the problem? And I include here, first, in the IoT OT. In the industrial Internet, what you talk, then there are like 2 different divisions: the people who are in the operation and the people who are in the IT. The IT are the people who are working with router, they are working with the cloud, they are working with the security in the Internet. However, the OT people, the operational people, they have been working in an isolated world. And now the executive said, you know, you need to open this. You need not only to implement more sensors, you not only need to create more business processes to use the Internet. You also need to open this world to the Internet, because you need some concepts like the cloud, like the big data, like the machine learning, etc. And this is more IT. And then they said, no, there is these guys are very worried about the security. So there is a big concern. So there is a big concern about these guys that don't want to open the facilities or the industrial control system to the IT. And this is a big concern because the people who are selling IT, don't understand the language of the IoT. So this is like, okay, you know, but we don't really know about your processes. We know about cloud, we know about big data, but I said, okay, it's good, but how can this benefit my enterprise? It's complicated. So this is a big discussion right now. The other thing is about the number of standards. So you mentioned before the OMA, but again, not for the consumer, because in the consumer there is a big battle between, you know, there are some companies who belong to 2 or 3 different organizations. So, when I was talking with these guys, I said, okay, if you are in this organization pushing for this kind of standard, and then also for another pushing for another standard, who will win? Okay, we need to be in both of them. So, and again, the delay in the decision, et cetera, et cetera. So there's a lot of standard, a lot of companies, and again, this is for me a blocking point. In the industrial internet, for instance, I was working the last 2 years with the Industrial Internet Consortium. I know that there are many companies investing in the security. They have a security framework. They recommend all the companies. There are more than, I think, 500 companies that belong to the consortium. And they have very good ideas on how can implement security. The reason is that not too many. In terms, for instance, the OWASP that we mentioned, in terms of the communication, GSMA, they published a report this year about the security for the Internet of Things. So there are many, many companies working for the cloud, et cetera, et cetera. Now, but so the IoT is very, very important market. And most of the company now that is important, but also the security as a sub-segment of the IoT is very important. So what are the companies doing in the security? So we found that the typical security company for the internet or for the communication, they don't really understand too much about the Internet of Things. So they have some product, you know, that are Internet of Things enabled, but there are not too many companies who really understand all the components of the Internet of Things. And there are other companies who has been, you know, starting from scratch. Like, you know, I have here the device, Bastille, the device authority, that they are growing from zero to create an end-to-end solution for the Internet of Things. When I was talking with many of these companies, what I see is that there are still not demand of this kind of security at a high level, that there are now developing some product, you know, but you know, with some recommendation from the chip vendor, like the Intel, like the Samsung, like the IRM, etc., Cisco for the networking. So it's like a fragmented market in which every of these are updating his product to enter into the Internet of Things. But because we don't know what are the vulnerabilities, we don't know exactly what are the attack vectors, they are now more reacting anti-attacks now than preventing. That's the reality. And yeah, okay. Okay, now go very quickly for the summary. Okay. Only for the summary. What the companies, and I can in the summary. So we see that the Internet of Things is nothing new. We have been working with the Internet of Things or something, or device connected or machine connected for more than 20 years. Because of the cloud, because of the cheaper, the communication, etc., now we are experimenting a growing number of devices and a growing interest in the Internet of Things. It's very difficult for now to understand what will be the threats, because I think that there are now many people thinking, how can they attack this new Internet of Things? And they will see. And the companies are now aware about this. And they are creating like a framework, internal framework, to prepare internally the organization to deploy the IoT in a more safety way. That's my conclusion. Thank you very much. Sorry for the delay.
Now you can hear me, yeah, okay. So thank you, Francisco. Well, you are South European. I understand that you cannot compress yourself on speaking. Yeah, you're out of time. But maybe we can have some questions on what Francisco, well, he gave us an industrial view, the point of view. We're missing that, or everybody's looking for the coffee. Okay, I can give one short question. So, okay. Do you see a framework that is more dominant on this area? Do you see that the big companies will have a consensus and they will go somewhere, or is they're waiting for academia to put the way, show the way?
Well, in terms of the framework, I don't see that there is any, or we can say that is only one framework. I think that there are, if we divide the internet in three big areas, the devices, the communication, and the application, I think that there are organizations working in each of these specific areas, but not one organization that can cover the whole end-to-end application. So for instance, I think that the Industrial Internet Consortium can be, well, you know, kind of framework that for the industrial internet can apply. The OMA can be for the security, something that we can standardize in the future with the GSMA. For the application, it's a little different. For the application, I believe that there is not any standard, because applications are 100, probably will be million if we include also mobile application, not only application in the devices, application in the cloud, application also on premise. I don't think that we have right framework, but what I know is that there are companies who try to certify an end-to-end solution. For instance, the telco operator. The telco operator, if you company want to enter into my network, I need to make sure that you are certified. So all the devices, all the applications need to go through a number of steps to be certified. Okay. And the same for the devices. There are some companies that, okay, we want to classify this like an IoT secure device. There are some companies in which, you know, the device vendor can, you know, provide these devices. They make all kind of tests, penetration tests, etc., and they can say, this is IoT secure. So for a company, it will be maybe in a few years very important to have this kind of certification. Right now.
Okay, that's good enough for me. But do you see also that the IoT is consumer driven? I mean, do you see that, because we are talking about 2020 and now we are 16, yeah? Okay, it's close, it's happening. We see IoT device coming in. Do you think that we'll have unsecured devices and then starting, I mean, this cat and mouse is always challenging, but we need to take the head, and us that we are the mouse to have prefixed by design the security. Yeah. We should not allow devices that be out in the market cheap, but they're unsecured, because we are talking about data and industrial control systems.
Yeah, well, what I feel is in the consumer side, it will be very difficult to control the security because it's driving by consume. So if you have now and again, all the companies are launching new product, stupid product, you can imagine. So that you can read one of my blog, there are stupid things. So if there is now in the Christmas Eve, Amazon, Microsoft, other companies that are selling something from wearable, from here, you cannot avoid that the normal user buy this. Another, because what we call the millennial or the young people, they are not aware about the risks. They feel like there is no risk to share the data, the password, etc. That's why I said that in the future there will be, you know, more attack, because with the social network, social engineers, etc., we can have more information from this guy that they bring his device to them. Okay, I'm sorry.
Yeah, no, I just want to say that your company, it's OYES.
OYES.
That means here in Spanish. So I hope you hear that the market is still immature for security. Yeah, you want to ask? They will blame you. They will blame you for the coffee. You can ask.
Just a small question. When you define standards, IoT standards and protocols, do you also consider industrial robots and intelligent robots? Because I haven't heard anything about, and we are building the future using them.
Like I said, when you talk about Internet of Things, the companies are including everything. So for the industrial, robots are part of this industrial automatization. And again, there are new protocols to control the robots, to create the robots, to automate more processes using robots that control other robots. And of course, but I think that for that, it will take at least another 5-10 years. But again, this is something that is happening now. One important thing is that, for instance, the German guys, that they have probably in Europe the more important manufacturing sector, they want to bring the factories from the China and other to Germany, also to Europe. In Spain, not too much. And they need this kind of automatization of the robot. So definitely, and there are many companies investing in the robot. Japanese are right now the most advanced, but
Thank
we'll
you.
see.
Okay, thank you all for your attention. I'm sorry for the 10 minutes late. Enjoy your coffee, enjoy the conference. We have the app, put your feedback there, and hope to see you next year also.
Thank you.